Welcome everyone. This is the AutoML Working Group Community Meeting on 7th of April. And let me start with sharing my screen. Can you see my screen?
Yeah.
Okay, great. I think we will start with AutoML. David here. Because first of all, we want to discuss about manifest refactoring, which is crucial for the release for the 1.3 of Kubeflow. I'm not sure that he is here right now. Yeah, because the main idea was, I don't know if you checked it, but currently the KDIP manifest is under installs and components section. And this is not the customized native. And if you need to install KDIP, you need to actually specify the load restrictor flag. And basically what we're trying to do, we're trying to support the new version of customize. And we try to reorganize manifest to make sure that that will work with a different version of customize. So I don't know, I mean, we can just move forward. Well, probably David is just connecting right now. Yeah,
yep.
We can just, okay, great. So do you want to start? Do you want to just give a quick overview?
Me give a quick overview of what I did?
Yep, on the refactoring.
So basically with now with the way the manifests are set up and referencing files that are not in or below the current folder, you need the load restrictor flag for customize, and that is apparently a security issue with phishing attacks, grabbing things from above. So basically what I did is each folder has a customization.yaml, and then that can get referenced above. The only thing that this does have as a side effect is that the catib config patch YAML needs to be duplicated into each folder because you can't reference that one directly. But I would argue that the way the folders are currently structured, with having a folder for each installation rather than a base and overlays, that's actually by design, because each installation folder is an entity on its own, and then it's not really expected behavior to reference files that are then not in that installation folder but part of a different installation. So I think that's the main thing about this this patch.
Mm-hmm. So basically, what we need to do, we just need to add the customization file in each folder that you did in this PR, and we need to think about the configuration patch to update the images for the OWL config map.
Yeah.
Okay.
I was also thinking that config patch, seeing as it's part of the controller, it would also be possible to just move that patch into the customization for the catib controller instead of having it in each installation directly.
Oh, okay. So do you mean just put it inside dash components controller?
Exactly. Just have it like move that file into that folder and then mention it in that customization.yaml, and then it doesn't need to be duplicated anywhere. I think that solves that problem.
I think we probably should directly specify it here without creating another subfolder, like without creating the subfile.
There's already it's the catib config.yaml. Isn't that already the same file?
Yeah, so basically, let me just open it. So I just opening your PR in the version. So basically, this is the file, the KDIP config here, and this is the file without specifying the image tags. So it has the latest version of each image. And why do we actually need this patch? Because if you just go to installs, and if you go to standalone, Here you specify the tag. So for the 0.11 version of KDIP, you will have the 0.11 tag here. So probably, as you said, like we can
Just
specify
add the tags in here, right? Is
Yeah.
that possible?
Yeah, but the question is how we can avoid the duplication of the files for each installs, for each overlays.
Well, you wouldn't if you add it to the controller folder.
Yeah. So
and
you mean
and
here?
just exactly. So you just edit. You just edit. Well, no, the cat config.yaml that's already here. Just add the image tags to that file, and then it. Like you're
Yeah. Okay. So do you mean like without the patch? So just adding it directly to the
yeah,
KDIP config?
because you're not really patching much. You have a file that defines everything but the tags, and then in each installation folder you're adding the exact same tag to it.
Yeah, this
So
was
why not just have the
actually,
tags in here?
yeah, that was done because like in the original like patterns of customized, you need to specify the image of the version inside customization file, so inside the overlay. And basically, if you specify some of the image version inside overlay, like inside, let me open it, like for example, like KDIP with Cert Manager, right? So if we open the 0.11 release,
Oh, I
so
think it's
if
in
we,
there as well. Yeah.
yeah, so some of the images will be, some of the text will be here, and some of the text will be inside the dash components folder. So if you think it will not confuse the user?
Well, I think there's a difference between what you do in the customization.yaml. Though there you actually specify the tags of the images that are actually being deployed by the manifests built by Kustomize, right?
Okay.
And the tags that are in this config map, these images are not actually being deployed when you deploy Katib, are they?
No, actually yeah, you're right. Like this is just the
Right.
config map of the images. Yes.
So this is like a config map of, I'm guessing,
Yes.
something that Katib deploys
Yes.
afterwards, but it's not
Yes.
actually part of the Katib deployment itself. And the images of the Katib deployment itself need to be in the customization.yaml. And yeah, the ones in here should obviously reflect or latest or whatever branch they're in. But I don't think it would be necessary to have a patch for it, for the image tags.
Okay. So basically, like your idea with the master branch, we will keep the latest version of the image. Like I think we can keep the latest tag here for each image, and for the release, for the release 0.11, we can keep the 0.11 version of each image here.
Yeah.
Yeah, but I think it makes sense. Yeah, only the question is like, will it be the use case when the user want to install KDIP using kubectl on the particular branch? So for example, if we select the release 0.11 branch, and if you want to install KDIP using kubectl, I think in any case, user should modify this file. So this will not be the problem, right?
Yeah, but so in the 0.11 branch, it would have the 0.11 tags in it, right?
Yes, for the KDIP config, yes, but for the controller, no. For the controller, we will not specify the image tag here. So,
yeah. But isn't that handled by the customization.yaml file in that,
yeah,
in that
but
folder?
yeah, by customization it will handle it. But I think it should be fine, right? So if user just want to use kubectl, probably they need to modify this images tag as well, at least for this release.
I'm not sure if I thought you could also specify image tags and new tags with kubectl and customize, right? You mean then it's just whatever they said in the customization.yaml for the
for customization, yes, you can specify like it, but if you're using like the pure kubectl, you need to just modify the without customization. But I don't know, like what others think about it. Like, is it fine if we specify the text inside the without the patch, so we specify the text directly to this config file? Any comments or questions here? Maybe John or Gaucho, what do you think?
I do not have other opinions here.
Nothing much
Yeah.
from my.
So you think it should be fine, right? If we skipping the patch inside the install folders.
Yeah.
Okay. Yeah, I think we probably also need to modify, but I will just let you know in the PR, we also need to modify the CI/CD script for this, because currently the CI/CD updating the patch inside the install. I don't know, what do you think, David? Should we keep the components and install, or should we keep the overlays and base here? What should be the best way?
So for overlays and base, what I would then do is have a base, which is, I think, now the standalone installation, or like one of the installs, whichever one makes the most sense to be a base, have that be the base, and then have the other ones be an overlay on top of that.
Okay. I see.
That's what I would think. So like same way Katib IBM is an overlay for a small overlay for the standalone, right? So it's the same idea.
Yeah, I think probably we can make it after we are removing the PV, because our next step will be completely removing the PV from the KDP install from the MySQL, and this can help us to avoid specifying all of these components inside
the persistent volume.
Yeah, because currently
I already removed that in my PR.
Yeah, you you remove it, but I mean, in that case, we need to specify the readness prop. I mean, if you can just check this issue. I think it's this one.
Because you mentioned that, and right. So you exclude the persistent volume for Katib with Kubeflow, and I'm guessing also with Katib Kubeflow Cert Manager.
Yes.
But I have a patch that removes the persistent volume, so that's how I got around that. With
currently it's probably can be the use case, but in the future we want to remove it completely. So after I think we will remove it completely, probably we can refactoring on the base and overlays to follow the proper design, and base will have the Katib standalone, install like Katib standalone customization file, and we can just rely other installs like Katib with Cert Manager, Kubeflow with Cert Manager, Katib with Kubeflow on this base. What do you think?
Yeah, that sounds good to me.
Okay. Yeah, I think, I don't know, should we make the new release? So what is the deadline? So I believe like you finished your like distribution already, but do we need
last week?
Do we need to make the release for this, or you can rely on the specific commits from the
well, what I'm doing now is I'm just referencing the branch on my fork that has the fixes I'd made to do that. But I think other than there's one small fix that's necessary for Knative and the OIDC auth service in the manifest branch or in the manifest repo. Other than that, I think it's only Katib that is causing the need for the load restrictor flag and the and I'm not even using old version of Customize, because everything works with new versions of Customize as far as I can tell. So
okay.
So I don't know. I think it's up to you guys. I can fix up the PR and do what we discussed here.
Okay.
Now, if you can send me some information on what would need to be changed with the CI/CD, I can add that as well.
Yeah, sure. I will just let you know.
And I mean, if it's all good, done, and merged soon, I think it wouldn't be a problem to have it added to the current release either. So
yeah, we can also like
switch for, right?
Yeah, we can just cherry pick this on the release branch, and in any case, if we need to, we can make another minor release like 0.11.1 for these changes. Yeah, but I think anything else that we probably will correlate with load restrictor. So as we use like the files from the components, that will not be the issue, right? So for the load restrictor, okay.
Yeah, so it's just because you're using these files that are not in or below the current folder. That's why you need the load restrictor. So
I see.
with that patch, you don't need that anymore. And for almost none of the components you actually need it. See, because here you're also mentioning ..cat of standalone. So it's going to a directory above, but because it has a customization.yaml in there, it's not a problem.
Okay, but if it doesn't have the customization, it just requires the flag to.
Yeah, it's
okay.
if you directly mention YAML files that are not in or below the current directory, then you need the load restrictor flag.
Okay, makes sense. Okay, any comments here? Any questions? How we will organize structure for KDIP in the next release versions? Going once. Okay, I hope everything will be fine. Thank you, David, by the way, for doing this. I think it will be really helpful for all of the releases, not only for Argo CD and for other distribution owners.
Yeah, I already think I saw some issues of people that were having trouble with customize because they were forgetting to use or the load restrictor flags on some things, right? And it was like,
yeah, I think it's always
easier for everybody if you can just use the latest and no special flags.
Yeah, and it's easier to use the latest version of Customizer instead of like 3.2 that we agreed on this release. Okay, thank you. So the next step that I want to discuss regarding AutoML is like roadmap for 2021. I don't know if anyone has any comments on this, but our next step, like from our working group, will be we'll try to support the multiple version in the 2021, which means like we will try to probably have the conversion webhook to follow the Kubernetes guidelines in different APIs. So basically all of the, after we graduating to the V1 of KDIP, all of the new features should follow the process from the alpha version to beta version to the V1 version. And I think that will be great if we have this kind of the process instead of creating the subfolders, what we're doing right now. Because if you just currently look at our repository, in our package, we have a version for each folder. Why we did it? Because before that, we had a different version for each type of the API. For example, for Alpha 3, we have each subfolder, so each metrics collector, each mock, but I think it's not necessary. So later on, we will try to have a single controller and probably conversion webhook to support different version. But overall, the next thing that probably we will try to implement is separating different aspect of AutoML in different CRDs. And I really want to hear the user perspective on it. So currently, if you try to submit KDIP experiment using the same experiment YAML, but what if we define the different APIs for HP tuning, for NAS, for feature engineering, for model compression? What other things, does it make sense? Will it be easier for you to understand what kind of process you are using right now? And I really want to hear some of the users' thoughts on this.
Yeah, I'd love to chime in, but I've never actually used Cathib yet, so
yeah,
not much I can say, Shuri.
Okay. Yeah. So basically, as I said before, right now, we try to support all of the AutoML features in KDIP, and we think that it will be better if we split it across different CRDs. So we will, I think we can try to submit an issue regarding to this, and we can try to creating the design doc, how we'll gradating to the V1, because once we gradating to the V1, we probably will have a separate CRD for HP tuning, for NAS, because currently we support only HP tuning and NAS, but in the future we want to support model compression and feature engineering, and definitely this require the different controller implementation, which we will support. So if you have any questions or any comments on this, we can just continue discussion under the design doc, under the issue we will create it. So other things that we will support in 2021 is I think there's some small parts with which we will completely migrate to the AWS infra. And we don't have the release process right now because we currently need to manually run the releases every time. But I think we will just follow the post-submit algorithms which we followed before. And the same with the UI. I don't know, like, do you have any comments? Like, are we going to support the new UI in the 1. For example, 0.12 release? In case?
Yes, I'm very confident. The main thing we need to define is how to handle our config maps for the different namespaces and some missing features in the form. And after that, we should be good.
Okay. Yeah. So, do you think we will support everything which we added in this project? Or do we want to add something or skip something? What do you think?
I think they're feasible, most of them, and we can do the most enhancement ones, which are show the logs from the suggestions controller and the trials. I'm confident about them, but I'm actually confident about most of them.
Just a quick question. You mentioned the config map in namespaces. Is that like a settings config map that needs to be in every namespace?
So here it's a little bit different from what we do for the Jupyter Web App. In this case, we want the config map to be copied on every namespace of the user. We have some default values, but we don't want them to live only in the Kubeflow namespace. And we want to make it a little bit easier for the user to, for example, have the web app that says, hey, I don't see your config maps. Let me create the default ones for you. And if they use, and have a page for them to edit.
Because that exact same functionality, I wanted to have for the Jupyter Web App as well, because that way, if it's not restricted by the administrator, of course, users can add their own images to that and the ones they've built, because otherwise they're all stuck with the same images for the entire cluster instead of the ones they actually use, right? So I think whatever method gets used to do that for Cat, it could then also be used for the Jupyter Web App.
Yeah, I agree, because Kubeflow is going towards this road of having separation between namespaces. So I also think that it's the natural progression to say, okay, let's have the config maps per namespace and have the web apps improve the user experience of managing these config maps. Mm-hmm.
Yeah, I think that can definitely will be helpful for the end user, so they don't need to actually specify in the back end or in front end. And so, because currently in Kedip, like we can use the predefined templates, which is like similar to if you think about Jupyter Web App, but here you can specify the images and you can use it in the web UI. Yeah, but I think this definitely will be handy for our applications, as you said.
I'll also create an issue for this so we can track this effort, so we'll have it documented.
Okay, and regarding to subject access review, do we need to have any changes in the backend as well?
Yes. So for Kubeflow, for Kubeflow, we will essentially just need to create a subject access review object and to check if the user is allowed to do any action they do. This will be something that we'll need to investigate for 1.3, correct? For this release.
Okay, makes sense. Yeah, so I think we will try to put it in the 0.12 release for Kedip. So I hope, yeah, because this is like a really huge effort, and really want to move forward with the new features for the new Kedip UI. And this will be our first step in this year. So other things that we will support, like parameter distribution, validation. This is not the huge effort on it, but I really want to hear anything else that you want to see in Kedip, like from the user perspective that you're missing. Any algorithms, any like suggestion regarding to SDK or how it's connecting with Kubeflow pipelines. really want to hear the voices like from our users. Any suggestions that you want that we need to support from the Kubeflow perspective? Yeah, I think, I mean, it's fine right now, but I mean, if you have anything, you can just comment on the issue and really try to make it super easier to run the Katib experiment and to actually, we have already like updated the launcher for pipelines, and you will see like more examples how you can implement the hyperparameter tuning in your pipeline and how to easily use different components in Kubeflow pipelines, because currently I think a lot of examples, they're not like specific to Kubeflow components in KFP, but as actually you definitely can use any sort of the Kubeflow components in your orchestration pipelines to perform the E2E examples in your MLOps infrastructure, which should be very useful. So any other comments regarding the AutoML, because I think we should just move forward to training. So any comments on the roadmap, on anything, any questions?
Just a question. It's about the multiple version. I'd like to, what are your thoughts about not moving to different versions of the CRD? I mean, what are the drawbacks we would bump into?
So this is not like, this is basically to follow the Kubernetes guidelines. So how does it work in Kubernetes? You have like the V1 Alpha 3, V1 Beta 1, and V1 version for each component, for example, like deployments. And after each version of Kubernetes, it's just moving some of the features from the older version to the newer version. So we want to follow the same patterns in Katib. Like, for example, if we have a separate CRD for NAS and for HP, and later on, like for other AutoML features, we want to have the, if, for example, we want to implement new feature to HP, like new API to HP, this API should graduate from the V1 Alpha 3, sorry, following Alpha 1 to V1 Beta 1 to the V1. And we can do it like for, I think, webhook, just creating the compression webhook. So this is possible in Kubernetes. And this is more like about it to have a proper design of implementing new API features.
And this would also need to take into consideration as well then if Katib will move to different CRDs for the AutoML and the HP tuning.
Yeah. This, I think we will try to submit the design doc to ask like community what do they think. Yeah, because currently the main gap that we have the experiment, and it's correlated with Kubeflow pipeline experiments. And another story, like, do we want to rename it to HP experiment and NAS experiment and other experiment? And we're still thinking what is the best name to handle it. Because in AutoML world, like, this is completely independent things. Like if you want to do model comparison of, or you want to do just a HP tuning, right? So I think it will be useful if we have this separation between different components.
I agree.
Yeah. So any last questions, or we can move forward to training? Okay, by the way, yeah, thank you so much to help to work on the releases. And yeah, I hope that in 2021 we have like more proper release process, and it will be easier to contribute because we're always welcome to the new ideas, new features. And AutoML is like super new for MLOps, and it has like a huge gap in Kubeflow. And I think it's a lot of parts can be improved and a lot of parts can be implemented better. And I think it's very valuable for MLOps world overall. Okay, so regarding to training, so Zhao, sorry.
Yeah, hi, this is T.
Okay, yes. Yeah. Do you want to share your screen to?
Yeah, sure.
Okay.
Maybe give me the co-host.
Sure. I just need to give you the access. 1 second. Okay, can you try to share your screen right now?
Yes, good. Okay, can you hear me?
Yep.
Okay, great. Yeah, we've just submitted a PR about like adding the paddle operator into the Kubeflow. But before that, I want to briefly introduce the paddle operator and EDO of what we are doing in Baidu, and hopefully we can. We know that paddle Kubeflow is an active community, and we really like to join this community, and maybe we can contribute some of our like what we did in Baidu, and then we can like cooperate with each other to have a better like project. Can you hear me?
Yep.
Oh, okay. So shall I start right now?
Yeah. Yeah, I think.
Okay, cool. Cool, great. So yeah. Hi everyone. This is Tijao from Baidu. I am the senior architect in Baidu, and I am also the Kubernetes org member and ELF Linux AI and Data Foundation TAC member. So we've been working around like Paddle for a long time, and recent years, like we use the Kubernetes as our foundation for Paddle framework in Baidu, and we made the Paddle operator, and we made the EDL, which is called the Elastic Deep Learning, and we'd really like to introduce those two projects to the community. Okay. Okay.
Yeah, we can see it. It's fine.
Yeah. Okay. So let me briefly introduce the Paddle framework first. Paddle is China's fully first open source deep learning platform, and it is also an agile framework for industrial development of deep neural network. Paddle's deep learning framework supports both declarative programming and imperative programming. Paddle also supports ultra large scaling and training for deep neural networks in Baidu. Paddle supports the training of deep neural network with 100 billion of features and trillions of parameters using data distributed over hundreds of nodes. And Paddle includes and maintains more than 100 mainstream models that have been polished for a long time in the industry. Some of the models have won major prize from well-known international competitions. In the meanwhile, Paddle has more than 200 pre-trained models to facilitate the rapid development of industrial applications. And we can see from the graph that Paddle projects are organized by four parts. The core framework at the bottom, the basic model bank like the NLP, CV, RAG, and speech, and the end-to-end develop kit like the Ernie, which is the NLP development kit, and some kind of really famous one, which is called Paddle class, Paddle detection, and Paddle OCR. Recently, Paddle OCR got over like 10,000 stars on GitHub, which is a really prosperous project. And also, we can see from the tool and components, we also give developers some kind of tools for them to easily develop the Paddle, like the auto DL and the Paddle Hub, something like that. Okay, next page. Okay, in terms of the large scale training, Paddle enabled collective mode training on multiple GPUs and support asynchronous parameter server mode training on GPU and CPU. Paddle use Fleet API for highly scalable distributed training. And at present, most of Baidu's intelligent services are powered by Paddle framework to provide the training and inference support. Well, Baidu is just related, just like Google, like in the United States, right? So we provided some like applications like the Baidu app, which provides the users the search and the recommendation streamline, and the Tieba and Baidu translation and Baidu map. And you can see from the figure above, Paddle has made a lot of optimization on some common models. As we can see in the picture, like some models like the CTR-DNN, Word2Vec, and BERT, performance have surpassed some other deep learning frameworks. Of course, this is our data. Maybe other frameworks that have their own like data, right? So in terms of the AI system, let's see how the Baidu infrastructure for modern machine learning and deep learning have evolved over the years. In 2011, we used Baidu's self-developed container technology called Matrix to containerize the training job. And then we used the Slurm framework to support distributed training. And then Baidu developed the online and offline hybrid scheduling system called the Normandy for maximizing the cluster resource usage utilization. Yes, and then with Kubernetes coming to our eyes in 2017, we used the device plugin directory to support the native hardware support like the NVIDIA GPU. And later, we with the CRD coming to our eyes, we implemented the training task operator based on Kubernetes CRD to support the native distributed training. And today, we mainly today's discussion is about a series of optimization we have done for the resource utilization, like the job fault tolerant, the task auto scaling, and the knowledge distillation training, which we've done recently. Okay. So we created Paddle Operator and the EDL project as the middle layer between Kubernetes and Paddle framework to handle the elastic training related stuff. Current EDL use Kubernetes as the foundation and provide user scenarios include predictive training methods such as the knowledge distillation, the reinforced learning, and hyperparameter search. And now with 3 major releases, Paddle Operator and EDL enable the snapshot-based fault tolerant, job autoscale, and also supports knowledge distillation natively. EDL also highly integrated with Volcano for advanced scheduling features like the GAN scheduling and the IO awareness scheduling to accelerate the training speed. With EDL enabled in Baidu internal cluster level resource utilization is above like 40%. 70%, and the job submission queuing time is less than 44 minutes, which is a huge progress. And the failure rate of the job is less than 5% now. And when Baidu Paddle do the large scale distributed training inside Baidu, and we suffer from some problem. One is when one of the pods got in the large distributed training got failed, the whole job failed. It will waste a lot of resources to restart the whole job. Another one is the low utilization of some inference card cluster, like some of the K40 card cluster, which we used for inference. While the training card cluster, like the V100, NVIDIA V100 card, is always out of resource. So we need to figure out a way to resolve those 2 problems when training in the Kubernetes cluster. In the release 0.2.0, we proposed the fault tolerant capabilities. Training tasks can be shut down at any time, and the subsequent recovery will be based on the final snapshot, which we can see in the picture, right? So at the same time, for the user side, we provide a non-intrusive API to make users unaware of the fault tolerant. The picture on the right is an example of our distributed training code. You can see that there's no code related to the fault tolerant. Okay, and then in the release 0.3.0, we introduced the knowledge distillation to maximize our cluster utilization. So for people who do not really familiar with the knowledge distillation, let's have a quick overview. Nowadays, the deep learning model is getting bigger and bigger, and the layer is getting deeper and deeper. In many scenarios, the larger the model and the more the layers, the better the model effect. But limited by the requirement of the inference speed and GPU memory resources, large models usually cannot be deployed directly, especially for those edge devices and mobile phones. And the models need to be compressed. The current mainstream compression method include the tiering, quantification, and the knowledge distillation. Among them, the concept of knowledge distillation is a state-of-the-art technology proposed in the distilling the knowledge in a neural network paper published by Hinton in 2015. It's a very classic model compression technology that converts knowledge from a complex model, migrate to another lightweight model. like the student model, to achieve the model compression. In fact, the so-called knowledge transfer can be understood as a training progress, which is to use the teacher model to train the student model. This training method is distillation training. After training a good student model, the student model can be used for actual deployment. As shown in the figure above, the training steps can be divided into 2 steps. The first is training the teacher model and use the technology, use knowledge of the teacher model to train the student model. Okay, so for the first, let's introduce those 3 types of knowledge distillation. For the first 2, the pure distillation training and the same network distillation training, there are 2 common ways in the industry right now. And the EDL based on Baidu's user scenario to invent the 3rd way to do the training. Okay, let's introduce those 3 first. The first one is called the pure distillation training. And the method of pure distillation training is much like the teacher recording the content of the lecture as a video and giving it to the student for self-study. And then the student learns by himself according to the course video. And therefore, offline distillation training is to first use the teacher model for inference and save the result in the disk. And then the student model use the samples saved in the disk and the inference result of the teacher model as a data set for training. In this training mode, the training of the student model is the same as the regular training, and the method is simple. However, this training method generally requires data enhancement and it takes up a huge disk space. So the application environment is subject to certain restrictions. And you can see on the picture, the second one is the same network distillation training, which is really common these days. The same network distillation training refers to push the teacher to put the teacher model and the student model into the same network, and the fixed teacher model parameters are only forwarded, and the student model is normally used for back propagation training, and this is and then sorry. Hello, can you hear me?
Yep.
Oh, okay.
Yeah, now we can't hear you.
Can you hear me?
Yeah,
Oh, yeah.
now we can.
Okay. So according to the same network distillation training, it takes the training method not only takes up a lot of computer resources for the teacher model itself, but also because the teacher and student have one-to-one binding relationship, the training of the student model completely relies on the teacher model. And the student model have to wait for the teacher model to output a batch of inference. The result can be trained. And the teacher model has to wait for the student to train a batch before starting inference for the next batch, which has a certain impact on the overall training speed. And the third one is our distillation and training method, which is called the EDL service distillation training. Compared with pure distillation training, EDL service distillation training decouples the teacher model and the student model. The teacher model is deployed as the online inference service, and the student model uses the client's identity to send samples to the teacher model in real time via the internet to obtain the inference result for training. This is like letting the model take the lessons online, and we use distillation reader for communication here. For more details, you can go to check our documentations about how we implement this. And let's talk about some advantages of doing that. The first is save the GPU memory resources. Due to the decoupling of the student model and the teacher model, the service distillation training can use multiple kinds of resources. That is, deploy the student model and the teacher model to different devices. Distillation networks are originally limited by the size of the GPU memory and were difficult to deploy to a single GPU card, which can be deployed to different cards in this way. And users can also flexibly set the ratio of the teacher to student according to the throughput performance of the teacher and the student, which means that multiple teachers can teach multiple students instead of maintaining a one-to-one tutorial model to maximize the training output. And the second one is improve the training speed. Due to the saving of GPU memory resources, the student model can be trained with a larger batch size. And at the same time, because the student model and the teacher model are in the different pipelines, the student model does not need to wait for the teacher model to end the inference before the training. And then combining those two above reason, the training speed can be improved greatly. And the third one is improve the utilization of the training resources. In particular applications, we can deploy the teacher model to an online elastic inference card cluster and use the computing resources of the online inference card to increase the throughput of the teacher model in the distillation task. At the same time, because the teacher model can be flexibly scheduled, there's no need to worry about task failure caused by the preemption of the online instance during peak hours. It is equivalent to transferring the resource requirements of the teacher for the training card to the online GPU card. When offline training resources such as V100 are limited, the online card, like the K40, is used to accelerate the training to save the valuable like V100 resources. In addition, offline clusters combined with the scheduling strategy, the teacher model can also be deployed to cluster fragmented resources or resources with low usage rates to make full use of the cluster idle and fragmented resources. And you can see on the right peak, it is the flow chart of the service distillation training operation. In this figure, you can see that student model sends samples to the teacher model and obtain the inference results, while the service side of the teacher model can be added and deleted at will and adjusted flexibly. Okay, now we'll see how Paddle operator and EDO leverages Kubernetes and Volcano to optimize the knowledge distillation training. EDL supports the elastic training with inference style service during training. It deploys the teacher model as online inference through Paddle serving, which is another Paddle project. In addition to the teacher and student training pods, a service registry and discovery module is developed by the EDL. Online inference services are elastic and are registered to the EDL service registry model for service auto discovery and fault tolerance. So EDL enabled the dynamic adaptation of teacher models online instance to maximize students' training throughput and resource utilization. With K40 inference card serving cluster and V100 card training cluster, EDL utilized Volcano for multi-cluster scheduling. And since Baidu Inside are always short of V100 resources for training, we use scan scheduling for knowledge distillation job to avoid the training resource from deadlock. And we also utilize the IO awareness in Volcano for maximize the RDMA usage in the training cluster. Okay, and then here's the benchmark data. In order to verify the effect of the EDL service distillation training, we use the pure training same network distillation training and the EDL service distillation training on the ImageNet dataset to train the ResNet 50 model. And then in terms of the accuracy, you can see on the picture, compared with the pure training, the distillation training improves the accuracy of ResNet 50 model by nearly 2%. Okay, and then you can see the service distillation training and the same network distillation training, they have the same accuracy. And the second one is the training speed. In terms of the training speed, compared with the pure training, same network distillation training takes up a large part of the computing power due to the teacher model. So the training speed is only around 36% of pure training with the same training resources. And the EDL service distillation training can use additional online P4 or K40 elastic resources and transfer the teacher's resource requirements from for the training cards to the elastic card. So compared to the pure training, it still maintains a training efficiency of 83%. And the speed is 2.3 times to the same network distillation training. So if you continue to increase the teacher resources, theoretically, the speed of the EDL service distillation training can be the same as the pure training. Of course, same network distillation training can continue to accelerate if resources are increased, but this will take up more valuable V100 training resources. And okay, here are the all kinds of materials we are talking about, the paddle operator and the EDL. For more information, you can check our projects, which are all open source, like the paddle, the Kubeflow, and the elastic deep learning. They are all open source projects. You can go online and check for all the documentations if you want. Thanks.
Thank you, T. I think it's great. Like, it's pretty exciting. It's pretty exciting, and it's a lot of things that can be improved from the Kubeflow perspective. So, any comments, questions? Because we have like 5 more minutes, but any comment, questions regarding to paddle operator?
Yes. So yeah, we just really like people to discuss more about how to like we've already seen that we've just made a pull request in the Kubeflow community, and we just we've already received lots of comments like why we don't use the common like libraries for the Kubeflow, which is pretty like interesting, and we really like those like comments, and we really like to discuss with the Kubeflow like community for that. Yes.
Yeah, because I think like from a training perspective, our main goal will be merging all of the operators in the one repo, because currently all of the operators are actually using the same source code, but they're located in different. It's hard to maintain, but it will be great if we can maybe create the design doc to handle all of these operators in the same repository, because they follow the same API patterns. And I think it will be great if paddle operator can support some of the common library.
Okay.
Which probably we need more like insights from you on the PR. So if it's possible, please let us know. I'm worried that Josh and Terry is not on the call right now, Jan. But because our next goal should be creating the merging all of the operators in the one repo under Kubeflow community.
Yeah, definitely.
Yeah. Yes. So from my understanding, you're willing to donate like to support paddle operator regarding to training to Kubeflow, right? And
yes.
Okay. So do you want to actually developing later on, like handling maintaining this under the Kubeflow organization?
Yes, we'd like to maintain the paddle operator under the Kubeflow organization, and it's already approved by our director, the paddle director, and we really like to hope that happen soon. Yes.
Yeah, because as I can see, like paddle like across community, you have a lot of different projects, and so specifically. Yes. You're talking about
let me say something. Okay, so some of the projects which are maintained in the paddle and others which we think is all good for us to build up the ecosystem with the cloud native, with the like the CNCF, with the like Kubeflow, or with the Linux AI and the data foundation. Those are the ecosystem projects that we really like to donate, and we also have some kind of other project which we think that it's just for the paddle, so we maintain it in the paddle organization.
Okay.
Yes.
Any other comments, because we have like 2 more minutes?
Yeah.
Yes, because from the community perspective, I think it will be very valuable. And if like you have a lot of customers who are actually using this operator, this could, I mean, help a lot with the training perspective from the Kubeflow community. So I think it's a really cool feature that we can implement. Yeah, thank you so much to just explaining this, and we hope that once you just figure out what kind of the API you can take from the common, please let us know on the issue. And I think we will just have a discussion about like how we want to merging, what is the next steps for the training operators, and how we want to handling them in the one centralized repo.
Okay, sounds great.
Okay, so unfortunately we have 1 more minute. So the quick presentation, can we just maybe handle it to the next meeting? So is it like from someone who just right now here added this comment in the doc? Okay, never mind. So any other questions, any last comments to the training part, or to pedal, or overall, what is the training vision in the next steps? Going once. Okay, so in any case, thank you so much for joining, and thank you T for the great presentation. I hope that we will just continue this collaboration, and it will be great. And thank you so much for joining, and I think I see you again next time soon. So yeah, keep us updated. Thank you. Bye.
Bye, everyone.
Bye.
Bye.